Hey everyone, welcome back. I think it's safe to say we're all fascinated by those truly groundbreaking ideas. Those moments when something completely new pops up, seemingly out of nowhere. Like, where does that actually come from?
You hit the nail on the head. It's the question, isn't it? What is the source of true novelty? That's precisely what we're diving into today.
That's right, we're taking a deep dive into the cognitive science of creativity. Now, when you hear the word creativity, you might automatically picture an artist or a musician or something like that. But we're going deeper. We're looking at the fundamental mechanics of how our minds actually generate new ideas. And what's really interesting is that there might be a link between this process and something you might not expect, evolution.
We'll be exploring some research by John Sweller, specifically his 2009 paper, Cognitive Bases of Human Creativity. What's particularly insightful about his work is that he finds a connection between the ways we learn and the ways we create. He suggests that the same principles that drive biological evolution are also responsible for shaping how we think when we're being creative.
So what's in it for you, the listener? Well, understanding these underlying mechanisms might give you a whole new perspective on where your own creative ideas come from. And who knows, maybe it'll even spark some new ideas for how to boost your own creative thinking. And don't worry, we're going to break this down in a way that makes sense, even if you're not a cognitive scientist.
Right. The core idea, as you mentioned, is quite remarkable. Evolution by natural selection is arguably the most powerful force for generating novelty that we know of. And Sweller's research suggests that our own minds operate with surprisingly similar information processing principles when it comes to creating new ideas and knowledge.
Okay, so let's back up for a second. Why does it feel like past attempts to really nail down how to understand and even cultivate creativity haven't been all that successful? We've been throwing around terms like brainstorming and thinking outside the box for years, but have we really seen a huge leap forward in how we think about creativity itself?
That's a great question. Sweller argues that one major reason we haven't made more progress is that a lot of the previous research on creativity hasn't really been grounded in our understanding of how the brain actually works, what's referred to as our cognitive architecture. It's like trying to improve a car's performance without actually knowing anything about how the engine works. If you don't have that fundamental understanding of the system, it's really hard to come up with strategies that are actually effective.
That makes sense. You need to understand the underlying mechanisms before you can start tweaking things. So what's the different angle that Sweller brings to the table?
He draws on insights from evolutionary psychology. The basic idea is that the same mechanisms that drive biological creativity, think of things like evolution by natural selection, may also be at play in human cognitive creativity. As Sweller puts it, evolution is unambiguously creative. It didn't just shape our physical bodies, but it also presumably gave rise to our very capacity to be creative in the first place.
Wow, so evolution itself created creativity. That's a pretty mind-blowing thought. So how does Sweller connect the dots between what's happening in the biological realm and what's going on inside our heads?
The argument is that because our brains, specifically our cognitive architecture, evolved through natural selection, they're likely to rely on some of the same core mechanisms and principles that drive evolution itself. It makes sense that if evolution can create complex biological structures and processes, then understanding its fundamental principles could also provide a framework for understanding how our minds generate new ideas and knowledge.
Okay, so what are the different types of knowledge that we need to consider when we're talking about this connection between evolution and creative thinking?
Sweller talks about two key categories: biologically primary knowledge and biologically secondary knowledge.
Biologically primary.
Primary.
It sounds like the essentials. What falls under that category?
Think of it as the knowledge and skills that we as humans have evolved to acquire really easily without much effort. Things like learning a language, recognizing faces, and basic problem solving. We pick these things up pretty naturally just by interacting with our environment and with other people without needing formal instruction. These primary abilities likely evolved because they were essential for survival.
It's like they're hardwired into our brains from the get-go. What about biologically secondary knowledge? It sounds like stuff we have to work harder to learn.
Exactly. This is knowledge that has become important in human culture relatively recently. It hasn't been around long enough for us to evolve specialized brain structures to deal with it. Think about subjects like math, history, science, those kinds of things. We don't just absorb these automatically like we do with primary knowledge. It takes conscious effort and often explicit instruction in a more structured setting. That's why we have schools and educational systems to help us acquire the secondary knowledge.
Right. It's the difference between a baby learning to speak versus an adult learning a new language. One feels natural, the other takes a lot of work.
Yeah.
So how does this tie back to the evolutionary analogy we were talking about?
So while our ability to learn secondary knowledge relies on the same underlying cognitive systems as primary knowledge, the actual processes are quite different. This is where Sweller lays out 5 key principles that he argues are shared by both human cognition and evolution by natural selection. These principles are really the framework for understanding the parallels between the two.
Okay, 5 principles. Let's hear them.
The first is the information store principle. In evolution, the vast store of information is the genome, the complete set of genetic instructions. In human cognition, the analogous store is our long-term memory. Think of it as the massive database where we store all the facts, skills, and experiences we accumulate throughout our lives. Research like de Groot's work on expertise in chess really highlights how crucial long-term memory is for thinking and problem solving. Chess masters don't just calculate moves far ahead, they recognize patterns based on a huge amount of stored knowledge. So a key takeaway here is that a rich and deep information store is essential for generating new ideas.
Makes sense. You can't create something new out of thin air. What's principle number 2?
The borrowing and reorganizing principle. In evolution, sexual reproduction combines and mixes up genetic information from both parents. This ensures that offspring are genetically diverse. In a similar way, humans acquire most of our knowledge from other people through things like imitation, listening, reading, and being taught. But it's not just about copying information. Our brains actively process and reorganize this new information based on what we already know. This principle is really important in educational settings, as cognitive load theory emphasizes. You want to present information in a way that makes it easier for the learner to integrate it with their existing knowledge. So it's not just about taking in new information, it's about weaving it into the tapestry of what you already know.
Like a DJ sampling different tracks and creating something new. What's next?
This one is especially intriguing. The randomness as genesis principle. In evolution, random mutation is the ultimate source of new genetic variation. It's the engine of biological creativity. Now, it's important to understand that it's not just about pure chance. It's a process of random generation and test for effectiveness. So, a mutation happens randomly, but if it provides an advantage, it's more likely to be passed on. Sweller proposes that human creativity might operate in a similar way. When we're confronted with a new problem, we often engage in a process of generating potential solutions, kind of randomly, and then testing them out. This process is shaped by our existing knowledge, which helps us to evaluate which solutions are more likely to work.
Randomness in creativity. Seems a little counterintuitive. We tend to think of creativity as something very intentional and deliberate.
Right, but think about those times when you're stuck on a problem. Haven't you ever just started trying different things, even if you weren't really sure if they would work? Those dead ends we run into when we're problem solving, those might actually be evidence of this random generation and testing in action. We try things out, and our existing knowledge helps us to figure out what's working and what's not. So this seemingly random exploration might actually be a fundamental driver of novelty.
Okay, I could see that. It's like trying to crack a code.
The
You just keep trying different combinations until something works. What's the 4th principle?
narrow limits of change principle. Now, if randomness is such a key driver of new information, there needs to be some way to manage all the possibilities that it could generate. The number of potential combinations can get really huge really fast. Evolution has mechanisms to limit this combinatorial explosion. In human cognition, Sweller suggests that our working memory plays a similar role. Working memory is that short-term mental space where we hold information and manipulate it. It's known to have very limited capacity. Think about Miller's famous magical number 7, or the research by Peterson and Peterson on short-term memory. Sweller suggests that this limited capacity might actually be a feature, not a bug. It provides a constrained mental workspace that prevents us from getting totally overwhelmed by a zillion possibilities all at once. Working memory acts as this temporary holding area between our long-term memory and the environment we're in. It's kind of like the epigenetic system in evolution, which mediates between the relatively stable genome and the ever-changing external world. So, the surprising insight here is that our seemingly limited working memory might actually be a crucial ingredient for focusing our creative explorations.
So it's not just a bottleneck. It's actually helping to shape the creative process by keeping it focused. That's really interesting. Okay, what's the last principle?
The final principle is the environmental organizing and linking principle. The previous 4 principles are all about helping the system, whether it's a biological system or a cognitive one, to operate effectively in its environment. This last principle focuses on how the system connects with and utilizes its surroundings. In human cognition, this principle is all about how our working memory serves as a bridge. It links information from the environment to our vast storehouse of knowledge in long-term memory and vice versa. One really cool thing here is that working memory seems to operate differently when it's dealing with information that's been pulled from long-term memory. It's like the capacity and time limits expand, as shown by research on long-term working memory by Erickson and Kinch. It means we can access and use a lot of stored information to make decisions and take action in complex situations. It's similar to how the epigenetic system in evolution draws on the massive amount of information in the genome to respond effectively to the demands of the environment. So, the takeaway here is that our interaction with the environment and our ability to access our existing knowledge are both crucial for shaping our creative output. Think of a chef in a kitchen. The ingredients available in the environment trigger memories of recipes and techniques stored in long-term memory, which can then lead to new and creative dishes.
So the environment and what we've already learned work together to shape what we can create. Now, taking all of these principles into account, how does Sweller actually define creativity within this framework?
He argues that true novelty really originates from that randomness is Genesis principle, that process of generating possibilities and then testing them out. While reorganizing existing knowledge can definitely lead to new and cool combinations, it's the random generation and testing process that provides the raw material for truly new ideas.
Okay, so if that's how creativity works fundamentally, does that mean we can get better at it? Can we use this understanding to enhance our own creative thinking?
Absolutely. Because this random generation and testing process is likely a biologically primary skill, something we evolved to do, it's very likely that we can find ways to make it even better. It's like learning a language. We learn our first language without really trying, but we can still improve our language skills with practice and instruction. In a similar way, we might be able to consciously encourage ourselves and others to engage in more of this exploratory thinking, especially in contexts where it might not naturally occur.
So it's not about forcing ourselves to be random, but rather about creating environments and situations that naturally promote this type of broad exploratory thinking.
Exactly. And another really important point is the crucial role of our existing knowledge base. The more expensive and well-organized your knowledge is in a particular area, the less you have to rely on pure randomness when you encounter problems in that area. Your random generation and testing can operate on a higher, more sophisticated level. As Sweller has pointed out, you can't invent a working light bulb if you don't understand things like vacuums and inert gases. In other
Yeah.
words, you need a solid foundation of knowledge before you can really get creative. So a key takeaway here is if you want to be more creative in a particular field, you need to constantly be learning and expanding your knowledge in that field.
It's like having a larger vocabulary. You can express yourself in more interesting and nuanced ways. What about things like brainstorming that we hear about so often? How do they fit into this framework?
Well, the effectiveness of brainstorming actually aligns quite well with the randomness is Genesis principle. When you're brainstorming, you're generating a lot of ideas quickly. It's a form of random generation, but it's drawing on your existing knowledge. And importantly, you're supposed to suspend judgment during the process. The idea is that by generating a large number of ideas, you increase the chances of hitting on something truly novel and effective. And what's interesting is that research has shown that individual brainstorming can actually be more effective than group brainstorming when it comes to producing original and high-quality ideas.
That's kind of surprising. We often hear about the power of brainstorming in groups.
Yeah, but studies have found that people working alone tend to come up with more and better ideas than when they're in a group setting. This might be because of things like social inhibition in groups or the tendency for group discussions to quickly converge on a smaller set of ideas. So encouraging that rapid, judgment-free generation of ideas, whether it's done individually or in a well-structured group, can really tap into that fundamental randomness that drives creativity.
So sometimes just letting the ideas flow freely is all it takes. Now, we also talked about something called the goal-free effect. How does that relate to all of this?
The goal-free effect is another really interesting phenomenon that seems to support this framework. In goal-free problem solving, instead of giving someone a problem with a specific target to hit, like finding the value of a particular angle in a geometry problem, they're asked to explore the problem in a much more open-ended way. For example, they might be asked to find the values of as many angles as possible. Now, what's fascinating is that research has consistently shown that this less directed approach actually leads to better learning and better overall problem-solving skills compared to working on traditional goal-specific problems.
It's like taking the pressure off. But how does not having a specific goal actually lead to better results in the long run?
Well, one key explanation is that goal-free problem solving encourages a much broader and more varied exploration of the problem. You're not constrained by trying to reach a particular answer. So in a way, you're engaging in more random generation of moves and possibilities. It's similar to brainstorming in that you're generating as many potential approaches or insights as you can without immediately evaluating them. This wider exploration might lead to unexpected and creative solutions that you might have missed if you were hyper-focused on a single goal. And on top of that, by not having to hold a specific goal in mind, you're freeing up mental resources that can then be used for more in-depth exploration and learning. Research has shown that this less focused approach can actually be more effective for learning new concepts and for fostering creative thinking. So sometimes the most creative path isn't the most direct one. It's about wandering around the problem space a bit and seeing what you discover.
So maybe sometimes the best way to find the solution is to not be looking for it directly. Just explore and see what you find. That's a really cool takeaway.
Exactly. It suggests that creating environments that encourage exploration, experimentation, and the generation of diverse possibilities, even those that might seem random or useless at first, can be key to unlocking creativity, especially when it's built on a strong foundation of knowledge.
So to wrap things up, the main takeaway from our deep dive today is that human creativity at its core might actually operate in a surprisingly similar way to the process of evolution. It's a constant cycle of generating new possibilities, often seemingly at random, and then rigorously testing them against what we already know. And this process is powered by the depth and breadth of our existing knowledge.
That's right. It's not about having some magical creative gene. It's a fundamental information processing principle that's at work in both the incredible innovations we see in nature and in our own remarkable ability to generate new ideas.
It definitely changes how you think about where new ideas come from. It makes creativity feel less like a bolt from the blue and more like a systematic process of exploration and refinement, even if we're not always aware of it. So listeners, I want you to think about how this perspective might change the way you think about your own creative process. How might you approach problem solving or learning differently now, knowing that randomness and testing play such crucial roles?
And here's one final thought to ponder. If our creativity really relies on this process of random generation and testing, how can we be more intentional about cultivating a rich knowledge base to fuel this process? And how can we create environments that encourage more of that testing phase, where we evaluate and refine the new ideas that we come up with?
Thanks for joining us, and we'll see you next time for another deep dive.